Hello and welcome back to my workshop. On this video, I'm going to be talking about 3D printing threads. But before we can talk about the 3D printing aspect of it, we need to talk about just the history and the science behind threads. So let's get going. So a brief history on the screw. You have early instances all the way back to ancient Greece. You see it in the Middle Ages, but it isn't until the Industrial Revolution where it is standardized. And that's when it becomes more common. A guy named Joseph Whitworth, I believe is his name, he makes a standardization of screws. Now, how do screws work? What do they do? Well, essentially what they're doing is they're taking a rotational force and making it go linear, okay? So you can see I put this screw on into this nut, and it's a bolt actually, as I screw this bolt, it's turning this rotational energy and it's sending it that way. So it's a great way of fastening something to something else. Just about every 3D printer has a threaded rod that as the motor turns, the threaded rods spin and then the plate will travel up or down depending on the direction the motor turns. So threads have a specific naming convention that they adhere to so that you know what kind of threads you're using. They have two big buckets. You have the metric and the imperial. For the purposes of this video, I'm going to be going over imperial because I'm in America and that's the most common type of threads that we use. All right, so right here I have a 3/8 16-inch bolt. And by 3/8 16, what I mean is, first of all, let's attack that 3/8. So 3/8 is the nominal diameter of this bolt. So it's essentially 3/8 or 0.375. If you want to know your nominal thread, so the 3/8 part of this, you can measure with calipers and that'll tell you your nominal diameter. And then 3/8 16 means that it is 16 threads per inch. So there's, in every 1 inch of this thread length is 16 different threads. So if you look here and you measured an inch, you could count 16 different threads. Now, there's a way to check that. So what I have right here is a thread pitch gauge. So what this has is it has a bunch of different thread patterns here. So you've got 12 threads per inch, 13, 14, 18, 20. So what I have, so I'm going to pull up the 16 right here. So 16 threads per inch, and I'm going to take it and I'm going to check it against my thread. And sure enough, yes, this is 3/8 16. So you can see that it has 16. That's the pattern, right? So measures perfectly. Cool. This is a very handy tool if you're trying to figure out, okay, I have this bolt, but I don't know what its thread per inch is. So that's really handy. What's really cool about these is that they actually will work with, you can 3D print a nut that works with a standard 3/8 16 bolt. And you can 3D print a bolt that works with a standard metal nut. It's pretty amazing. This right here is a Starrett card, and I got this when I was in machinist school, and it's a really handy tool. It has a lot of information. I won't go over all that it has here, but what it does help you understand is the common thread sizes, okay? So I'm gonna go here, and you can look and you can see 3/8 16 is right here. Well, the next thread size, common thread size, is 3/8 24. So what does that mean? So 24 means that it's 24 teeth per inch, which means it's a finer thread, which means it takes more times to spin to get more movement, okay? So if you have 3/8 16, you only have to turn it a certain amount to get it, to move it an inch. If you have a finer thread, it will turn slower. So just a few differences between the fine thread and a coarse thread. A coarse thread, it is stronger and softer materials. So when you're 3D printing, I highly recommend doing the coarse thread. For fine thread, it allows for finer adjustments. So it turns slower, allows you to adjust things slower. As you turn, it moves less. So a couple of different reasons. There's a lot of other reasons why you would maybe want to go fine versus coarse. Just know for our purposes, I recommend a coarse thread, so because it is more durable and plastic. If you're not 3D printing a thread, there's different ways to do it out of metal, on a lathe, on a mill. You can hand make them with different tools. Basically, I just want to show you a couple of the hand versions. We won't get into full-on machining. That could be for a later date. But the two things that I want to point out is we have a tap and we have a die. So a tap looks like this. And essentially what you would do is you would drill a hole that's a little undersized, and then you would turn this by hand, and that would cut grooves, it would cut your threads into that hole. So this is for internal threads. So if you were to cut the threads inside this nut. To cut threads, you really have to twist and be careful not to break your tap, and you want to use cutting fluid and things like that. So that's how you would cut internal threads. For external threads, or like cutting a screw or a bolt, you would use a die. So I have this die here, and that is what you would put your screw on, and you would take a blank piece of metal that is properly sized, and then you would screw this on it, and then as you screw, it would leave threads. So those are two tools that are useful when cutting threads, internal and external. You have internal and external threads. We'll talk about these more in a little bit because they actually may come in handy for your 3D prints. So stay tuned. All right, let me give you one more tool that you can use when you're trying to figure out what your thread is, if you're trying to match a thread. I've got one of these. It is basically a series of thread checkers for internal and external. So let me show you what we got here. You can see it's got the different thread types. And so right here, I've got 3/8/16. So let's take my nut and check it against my threads. And sure enough, that screws on. So I know that's 3/8/16. And we can flip it over and we can check it in my, the internal or the external. And we're checking that, and sure enough, that screws on. So if I were to go over to the 3/8/24 and try to screw it in, it gets stuck. So it's not 3/8/24. So if you find, okay, I know its nominal diameter is 3/8, but I don't know if it's 24 or 16, then you know, and you don't have one of these guys to check it, then you can use one of these guys. And before I had this, I actually would take bolts to Home Depot, and they have these like mounted on the wall, and you can actually check them there. And I got tired of doing that, and I was like, I just want one for my house. So ordered this off Amazon, and it's been really handy. All right, so let's look at this hardware store website so you can see kind of the common thread sizes. So we just first go to just hex bolts. You can just start to see, okay, here's 3/8/16. Okay, so we know what that means. 1/2 inch 13. 1/2 inch is the nominal diameter, and -13, that's the 13 teeth per inch. Let's look over here. If we go to size, we can say, okay, let's say I want a 3/4 inch nominal diameter. So you can get a 3/4 inch, 10 teeth per inch. Okay, that's kind of interesting. Let's clear that, and let's see. If we do thread style, if we want fine thread or coarse thread. So let's, we're wanting to do coarse thread because we're 3D printing and it's stronger, right? So this is going to keep it to coarse thread. So 1/2 inch 13 is a coarse thread. Let's see if we want to do, let's say we want something 1/4 inch. Let's see. 1/4 inch, so 1/4 inch 20 is a very common thread type. So that's a nice option as well. So you can see how being able to know, being able to speak this language is going to really help you in the real world as well. All right, let's get into 3D modeling a thread. There's a couple of different ways to do it, and it's pretty easy as long as you know the thread type you're looking for. All right, let's make a thread in Fusion 360. There's a couple of different ways to do it, and it's fairly simple. All right, let's just start with creating a sketch on our bottom plane, and we're going to create a circle, and let's make it our nominal size, which is 0.375, which is 3/8. 3 divided by 8 is 0.375. All right, so we've got a circle. Let's extrude it 0.1, let's do 1.5, boom. Okay, so we have our the beginnings of a threaded rod here. I'm going to go under Create, and I'm going to go to Thread, and I'm going to select this outer dimension. So you can see it already found what its nominal dimension is, and now it's already wanting to put 3/8 in. So you can change that. So we can go to 3/8 24, which is the fine thread, but we're going to keep it at 3/8 Now, notice it does not, it's not modeled in there. So if I were to print this, it would just still look the same. It would look just like that. So what I want to do is I want to model those. So I'm going to do that, 3/8 and you have to hit this modeled. All right, so if I hit OK, now it's modeled into the face. So in a matter of seconds, I've actually given this threads. All right, so let's talk about how to make an internal thread. We're going to go turn on this body, and let's create a circle on here, and we're just going to go in the center. We're going to do 0.375, boom, finish sketch, and then I'm just going to extrude that all the way through. All right, so now I have this hole. So I can do the same thing. I can come over here to thread, and it already sees the nominal dimension, and then 3/8 and I just have to hit modeled, and then boom. Now I have a modeled hole through this part. Let's talk about another tool that can do threads, and that's the hole tool. It can do an internal thread pre-built with just making a bunch of holes. All right, first of all, I just want to create a sketch on here. I'm going to create a rectangle, and I'm not going to really care where I want to put it. I'm just going to do a rectangle right there. All right, so I'm going to do finish sketch. Now I'm going to go up to the hole tool, and under here where it says placement, I want to click this from sketch. So I'm going to pick all the points that I want this to make a hole. So I'm making 4 holes here. All right. Now there's several different choices you can make here. You can do the distance, how far you want the hole to go, and we've done that with extrude. You can do all the way through. You can do to a certain plane, or you can do a specific distance. Like if you set it to distance, the distance right here is 1 inch. I'm going to set it to 1/2 inch, and you can see how it only goes 1/2 inch down. So I'm going to change that back to all, so it cuts all the way through. All right, so that leads me to this next setting, which is either the counter bore or the counter sink. So if you look at the shape of the counter bore is using this guy, is making room for this guy so that you can mount this screw flush with the surface. The counter sink has this angular look, and you can mount this flush with the surface. So back to Fusion 360, you can see if I change it to counter bore, then I've got this these different widths here. So let's say I want my counter bore to be 0.4. You can make it bigger, you can make it wider. So now you have these rooms. Then you can have how deep you want your counter bore to go. So say you have you want it to go really deep. So you would measure this by with your calipers and figure out how you want your counter bore to go. The other thing is you could do the counter sink. Now the counter sink is going to be setting here. So you've got your degree of counter sink, you've got how wide, so let's do 0.5. So you can see now it's putting this angle in there. All right. So it's all adjustable. It's all, yeah, you can adjust any of it. You can go really crazy with it. But yeah, you would just want to measure your the head of your screw and just determine how big that needs to be. But right now I'm just going to keep it simple and do a simple hole type. All right, so now the next step is, do you want what do you want it tapped like? Do you want it to be a tapered tap? Do you want it to just be clearance for a hole, for a bolt, so that it will go all the way through and it doesn't intersect? Do you want it to just be a simple hole, or do you want it to be tapped? So in this case, we want it tapped. It doesn't know my 3/8 outer dimension, so what I have to do is go and I need to tell it to be 3/8 or 0.375. All right, and then it knows 3/8, that's perfect, and I've got modeled checked. So now I'm going to hit OK, and now I've got 4 holes modeled into my part. Okay, before I go too far, I'm probably going to use screw and bolt interchangeably. Technically, a screw is what you would, fasten into something like, into wood or something. Everybody's driven a screw into a board, but it's also technically has threads. A bolt is generally what you see here. It is something that is fastened into something. It either requires a hole that has the same type of threads or has a nut. So just know I'll probably say screw and bolt interchangeably. Just know that what I'm talking about in this video is generally your bolt. So just forgive the slip-ups. All right, let's talk about 3D printing. If I were to 3D print a bolt and a nut with just the settings that Fusion 360 uses, there would be too much interference. They would not screw on. Because they are printed exact. There's too much friction. There's no way for them to actually screw on because they're taking up the same space, right? So what we have to do when we're 3D modeling, and it's really annoying, and I wish Fusion 360 would add a setting for 3D printing, but they haven't yet. You have to actually go in and model in a little bit of an offset to allow for the two pieces to screw together. So when I first made these, this nut and this bolt, they wouldn't actually screw on. So I had to add that offset to make them work. But now with the proper amount of offset, it screws on just perfectly. So when you're modeling, just know if you were to not add that offset, you're not going to get your parts to go together. But I'm going to show you how to offset. So let's make this our project. We're going to make a nut and bolt just like this and just like this. All right. So first thing I'm going to do is I'm going to measure the from flat to flat on this bolt, and it is 0.5. Let's just call it 0.55. All right. So we know that distance. So we're going to go into Fusion. We're going to create a sketch on the bottom plane, and I'm going to create a polygon and doing a circumscribed polygon. So we're going to go here, and so the distance between this outer side and this center is, we're going to do 0.55 divided by 2. All right, so there we go. So it's 0.275. Perfect. All right, we're going to finish that sketch, and now I want to know how deep is this? 0.24. Let's just call it 0.24. All right. So we're going to extrude 0.240. Boom. So we got the makings of a bolt. Now I'm going to create a sketch on this same plane. And because we've been working off of the center point, we can just create a center circle right here. And we're going to make it 0.375 because that's the nominal diameter of our screw. That's just 3/8. All right. So I'm going to finish sketch. And how long is this guy? From where the threads start and to where the threads end. I'm going to call that 1.5 inches. All right, so let's extrude 1.5 inches. Boom. All right, so we are almost there. We're going to go up to our create tool, and we're going to use our thread tool. All right, and we're going to tell it to be modeled. All right, and we got 3/8, 16, and 0.375, and we're going to hit OK. All right, so we have the makings of a thread. We have our bolt basically. But one more thing I want to add to the mix is that it's really important to add a chamfer into your the tip of your bolt, because that's going to make it screw on easier. That's going to help it find the thread easier. So if we were to go in here and try to chamfer this, it's going to be really tricky because you can only select some edges. So what we need to do is when we're creating our thread, let's go back and edit it, and let's just tell it to, we don't want it full length. We want it to be full length to the bottom, but from the top, we want to just give it a little bit of, let's give it that 0.5 at the top and then go all the way down to the bottom. All right. So there we go. So now we have a little room to make a chamfer. So now we're just going to go and we're going to do chamfer, and we're gonna try. Let's try that again. We're going to do chamfer. We're going to select this top circle, and now we're going to chamfer it down until it intersects right there. So you can see now this point right here is where the thread will interact with the bolt. with the nut. And so now we have a little bit of a chamfer. So you don't have to go that extreme with it. We can actually come back here and we can say, instead of the offset starting here, I want to start 0.03. And then we can come back and we can change our chamfer. It doesn't have to be so aggressive. So that's probably closer to what it should look like right there. Okay, so let's make the nut. So I measured, you can see that it is the same width as the bolt. So I'm just gonna go back and I'm gonna use my first sketch here, and I'm going to extrude that, and let's figure out how thick it is. So it is 0.330, all right? So we're gonna extrude 0.330, and it's gonna wake up, there we go. All right, so now let's just go in and let's create a sketch on that face. We're gonna do 0.375 like we did before, and we're gonna hit finish sketch. We're going to extrude, and we're gonna go all the way down, boom. So we've got our hole. So next we're gonna go to our thread tool, and we're gonna create a thread here. We're gonna turn it on to modeled, right? And we got 3/8/16 is our thread type, and we're gonna hit okay. All right, so that kind of works, but remember, we don't have a chamfer on this. So having it start the thread is gonna be a little difficult. It'll work, but it's gonna be a little difficult. So here's a trick you can do. So we'll go back in time. So we're gonna drag our timeline head right here, back in time, and I'm gonna go and I'm gonna create a chamfer on this line and on this line, and let's just do 0.03. So we have our chamfer, boom. All right, so now what I want to do is I'm just going to drag that forward in time past the thread, and now we have a chamfer on that hole. Now, why did I go back in time to make it? Well, let me show you. So I'm going to delete it. If I were to try to make a chamfer right here, again, you can see I can't select it, all right? So you're gonna want to go back in time to make your chamfer. So again, go back in time, go make your chamfer, boom, and boom, and 0.03. Doesn't have to be super big. Hit okay, now drag that forward in time past the chamfer, and now you've tricked Fusion in 360 to let you do a chamfer on your nut. Okay, so there you go. So let's turn on our bolt. All right, so next let's just move our nut. We're gonna rename our nut, and we're gonna move our nut up just so that it's not intersecting there. All right, so to give it clearance, you just need to select two faces and then make it smaller. So let's start with our bolt. We're gonna select this face, so the top face of the threads, and we're gonna rotate under, and we're gonna select, hold down shift and select the bottom face. So now we have two faces that are being, that we want to adjust. So now you're gonna go to this tool here, the press pull tool, and we're gonna click that, and I just want to go negative 0.003. And that's gonna make it just a little bit smaller, okay? And if you're doing a bigger thread, like if you're doing like a 3-inch thread, you may need to go more than 0.03 of an inch. But for a 3/8 0.003, which is basically a human hair, we just need a little bit to allow it to screw on. All right, so we made the adjustment to the nut, or to the bolt. Let's make the adjustment to the nut. All right, so this one is the same process. We're gonna take this face, we're gonna rotate under, and we're gonna get the same face on the underside, boom. So now we've got those two faces, and we're gonna go to the press pull, and we're gonna go negative 0.03, and boom. So you can see when I undo and redo, all it's doing is making those a little bit more, right? A little bit smaller. And then we have the clearance we need to 3D print this. So that brings me back to my tap and die. So if you don't want to 3D model offset into your part, you can actually use a tap and a die. If this nut would not screw onto this bolt, you could actually take your tap and you could run it through it, and it would actually cut the additional offset that you need. Then you could take the bolt and run it in the die, and that would cut the threads that you need to give you that offset. So you'd already be starting with the proper threads, they just need a little bit of clearance. And that's what you can use the tap and die for in this instance. The tricky thing there is just not everybody has a tap and die set, and it's just an extra step that if you just wanted to 3D model and have it work, that's when you would need to use the offset. All right, so the last thing I want you to know about 3D printing threads is please, 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 when you're setting it up in your slicer, do not use supports. It's going to be a mess. It's so intricate and so tiny that it'll just fuse to it and you'll hate yourself. So however you set this up to print, make sure that you're setting yourself up so that it's being printed in a way that you can do it without supports. So usually that's, facing, so I printed this like this. And so it was able to do those overhangs because they're so small. And I printed this guy like this with the hole facing up, and yeah, it printed fine. All right, so let's review. So we've gone over the history of the thread, how to know what kind of thread you're working with, how to 3D model a thread using the thread tool and the hole tool, and we've 3D modeled a recreation of this bolt and this nut. No, sorry, this bolt and this nut. And we talked about giving clearance to your nut and your bolt in Fusion 360, or using a tap and die in order to give you the clearance you need for it to actually work. All right, so that should give you all you need to make threads in your 3D printed parts. So get out there, start making threads, get some 3D prints going and test it out and see how it works. Now remember, you can combine these, so you don't have to use a 3D printed bolt with a 3D printed nut. You can create nuts or create holes for metal bolts. So feel free to mix and match materials, because this is definitely going to be stronger connection than this guy for things that you may be making. So yeah, feel free to mix and match. All right, that's all I've got for this week. Thanks for watching. Please like and subscribe. Leave me a comment. I'm happy to help in any way I can, and I hope you have learned something and this is helpful in your journey in Fusion 360 and in making in general. All right, I will see you on the next video. So satisfying.